Welcome to the first of 3 videos on solving simultaneous equations using algebra. There's 2 methods that we use to solve simultaneous equations algebraically. One of them is elimination, which we're going to do here, and the other is substitution. The third video, I said there were going to be 3, is me showing you how to do this stuff on CAS. There's a solve function there that you should be aware of. All right. So, if you remember back to when we did this using the graphical method, equations like this are straight lines. Even though they're not in y equals mx plus c form, which is probably the form you're familiar with, it's still just an x to the first power and a y to the first power. So they're just linear equations. And wherever these 2 linear equations intersect, that coordinate gives the x and y values that make both of these equations true. That's what it means to solve a simultaneous equation. Okay, so how do we do this elimination method? Got the steps written out here. Let me just follow them one by one and we'll see how we go. All right, steps. Label equations as 1 and 2. 1, 2. All this means is this top one, x plus y equals 6, is equation 1. And this second one, 2x plus 4y equals 20, is equation 2. Okay. Choose a variable to eliminate. Doesn't really matter which one you pick. It's just you generally pick the one that looks like it's going to be easier algebraically. Okay. In this case, I'm going to pick the x. It's not too much difference, but that's the one I'm going to pick. Okay. Multiply equations by a constant until variable, in this case x, because that's what we picked, has the same coefficient. All right, well, you can see that in the second one, it's a 2x, and the first one, it's an x. We want to make this x into a 2x. Okay, let's do it. So the way we do it is we go equation 1 multiplied by 2. Because the thing is, if you just put a 2 here, it's not the same equation anymore. However, if you multiply everything in the equation by 2, the equation stays the same. 2x plus 2y equals 12. If you want to convince yourself that this is the same equation, think of a solution that works for this first one. Let's say x is 2 and y is 4. 2 plus 4 equals 6. True. Does it work here? 2 times 2 plus 2 times 4. Well, 2 times 2 is 4. 2 times 4 is 8. 4 plus 8 is 12. It's the same thing, okay? So, this new equation, we're going to call 1 star. Modified version of 1. Okay? And we're just going to write out equation 2 again. That one hasn't changed. So its label is still 2. Okay. Subtract one equation from the other. Notice now that if we were to go 2x minus 2x, that would be 0. That's where the elimination happens. Okay? So I'm just going to write 1 star minus 2. All right. And then we've got 2x minus 2x is 0. That variable has been eliminated. All right. I'll just write it out fully. 2x minus 2x plus 2y minus 4y equals 12 minus 20. Okay. There's your elimination. And now we just have to clean up the rest. 2y minus 4y is negative 2y. 12 minus 20 is negative 8. solve for what's left. Okay, we're going to solve for y. We've got negative 2y equals negative 8. We need to divide through by negative 2. Y equals 4. That's nice. Sub-result into original to find the other variable. Well, if we put a 4 into equation 1, sub y equals 4 into equation 1, then we've got x plus 4 equals 6. And you can probably already see what the solution is. X equals 2. Okay. The other step I should have put there was check. Check if your answer is correct. How are we going to do that? Well, we can substitute our variables into our equations and see if they're both true. We certainly know that 2 plus 4 is going to be 6. So equation 1 is going to become 2 plus 4 equals 6. True. And equation 2, 2x plus 4y equals 20. 2x was 2 plus 4 times 4. Is this true? Well, yeah, because 2 times 2 is 4. 4 times 4 is 16. 4 plus 16 is 20. Also true. So that's very nice. That's our solution. Let's try a more difficult one. Okay, here's a harder example. There's a bit of negatives and that kind of thing there, so you've got to be a bit more careful with your algebra. That's not a problem. Let's just follow the steps like we did before. Label it up. 1, 2. Choose a variable to eliminate. Now, this x looks like there could be difficult with the negatives and stuff, whereas this one's just 2 and 4. So I'm going to try and eliminate y this time. Okay? And you can probably guess that I'm going to be multiplying this equation 1 through by 2. Why is that? Because in equation 2 it's 4y, and here the 1 is 2y. So if you multiply 2y by 2, you make it 4y, and then you can do your elimination. Okay, so let's multiply 1 through by 2. All right, negative 3x times 2 is negative 6x. 2y times 2, 4y. And 6 times 2 is 12. And we'll call this 1 star. X plus 4y equals negative 9. I will say, it doesn't actually matter which one you eliminate. As long as you do your algebra correctly, you should end up with the same answer in the end. All right, so next we're going to go and subtract one equation from the other. Okay, let's do that. Let's go 1 minus 2. Okay, negative 6x minus x. Gotta be careful here. So we'll write it out fully. Plus 4y minus 4y. That's where your elimination's happening, remember? And 12 minus negative 9. Be careful. Careful, careful. Okay. Elimination. Negative 6x minus x is negative 7x. 12 minus negative 9 is 21. It's not too bad. Divide through by negative 7. X equals negative 3. Good. And now we substitute back into the original. So sub x equals negative 3 into, and again, it doesn't actually matter which one you sub it back into, because this is meant to be a solution for both. That's the whole point. So you pick the easiest one. And I'm gonna pick number 2 because these numbers are both positive. Let's see what we get. X is negative 3, so that's just negative 3, plus 4y equals negative 9. Okay, that's not too bad. 4y equals, well, we're getting rid of this, so we're going to plus 3 to both sides. Negative 9 plus 3 is negative 6. Divide through by 4. Negative 6 on 4, which is negative 1.5. Or negative 3 on 2. Okay, that's good. Let's do a check. We'll sub these two into the first one. Negative 3x, negative 3, plus 2y, negative 3 on 2. Does it equal 6? Well, it's not immediately obvious, is it? Let's do a bit of working. Negative 3 times negative 3 is 9. And 2 times negative 3 on 2, if you look at that cancellation there, is negative 3. So that is indeed 6. Good. And the next equation, this one, x plus 4y equals negative 9. Negative 3 plus 4 times y, negative 3 on 2 equals negative 9. Is this true? Again, not super obvious that it is, but let's do some working and see if we can get it. Negative 3 plus, what's 4 times negative 3 on 2? Well, that is negative 12 on 2. Okay, that's good. Maybe you can see that it's true now, maybe not. We'll just keep going. What's negative 12 on 2? It's negative 6. And now you can probably see that negative 3 plus negative 6 does indeed equal negative 9. Again, true. Happy days. So our solution is, just to make it super clear, x equals negative 3, y equals negative 3 on 2, or negative 1.5 for you decimal lovers, although when you're in methods, fractions are the preferred thing to do. All right, great. Thank you very much. See you in the next video.